So hi everyone, I'm Justin, CTO and co-founder of Althea, and also the lead designer and developer of Gravity Bridge. And today I'm going to be talking to you about Gravity Bridge, its design, its advantages, and why sort of the mantra during the design and development has always been that we wanted to build a radically simple bridge. And what I mean by that is that originally we were developing what would become Gravity for the Althea blockchain. Now, for those of you that don't know about Althea, you can visit althea.net. Althea is a decentralized platform that allows routers to pay each other for bandwidth. So it makes it possible for anyone to buy bandwidth from anyone, democratizing internet service. So one of the things we need for the Althea blockchain is a bridge so that we can have access to stablecoins like DAI for users to transact in. And so we originally set out like, okay, we're going to build a bridge because we need one. Particularly, we are targeting the Cosmos SDK ecosystem, which I'll get into in a little bit. So our thing was, well, we need this bridge. It's one of a million other things. We got a pile of things to do. We should try and make it as simple as possible. And the really incredible thing about that is that as the design evolved and as we spent time working on it from this premise of simplicity, we realized that what we were making was really generally useful, that simplicity was a good thing to have and a really compelling property in a bridge. So the things that we really needed were that we needed the bridge to be straightforward to operate, reasonably easy to debug and develop, and the one big complexity adding requirement was something Althea users needed, which is that we wanted withdrawals from the bridge to be unusually cheap, like really drastically cheaper than normal, because a typical decentralized bridge, when you withdraw tokens from the other side of the bridge back to Ethereum, costs somewhere between 200 and 400,000 gas. So I did the math before I came up here, and that's about somewhere between $200 and $400, which is nice and convenient round numbers today. So that's a lot. And if you're doing DeFi, this isn't such a big problem because eventually your trade just becomes profitable enough that you can pay the gas. But for Althea users who are moving bandwidth through their home and making money with their home router, this is a punishing amount. So we really needed to give them their liquidity at sort of a lower cost. So what we did is that we ended up really exploiting the properties of the Cosmos SDK ecosystem, and taking some ideas from rollups to really dramatically decrease the cost of operating Gravity. So here I have this really great I have this really great graph from a Medium blog post, which I think most of you should go and read. It's called, and I'm going to butcher this because I don't have my notes in front of me, Cross-Blockchain Bridges, Building Networks of Crypto Networks. And it's a research blog post that I think does an excellent job of showing a field that is really fragmented right now. Everybody has a different design. It's kind of like blockchains, except it's built on top of blockchains, so it's twice as fragmented and twice as weird. Because everybody is doing something slightly different when they're different with their design. And the way I like to mentally picture this is that it's like the early days of flight, where people didn't really know if more wings was a good idea, or if boat planes were going to win because runways were hard to build. And that is the state of blockchain right now, and it makes for a really interesting space engineering-wise. But to finally get to what I'm trying to talk about here, you'll see the Gravity Bridge is one of the few over here in the trustless column. And trustless means that it mirrors the trust properties of the blockchain it runs on. So if you can trust the Althea blockchain or the Cosmos blockchain that is running this bridge, then you can trust the bridge just as much. And this is a really hard property to get. So of these designs, Gravity Bridge is actually the only one that is not implementing a light client for the actual chain consensus that it is bridging across. And this is sort of a statement about bridges in general, is that how do you know thing A happened on chain B? And the answer is normally that you take a look at the consensus headers of chain A, and you say, oh, hey, like we have this block. I'm going to submit a proof to chain B. And you write some code on chain B, which interprets this proof and says, okay, that's right, and lets things go through. And then in the other direction, you have an oracle. Now, this is where that cost comes in. This is where that 200 to 400,000 gas that I was talking about earlier really becomes a thing. Because unfortunately, if you are bridging to Ethereum, which we are bridging, Gravity Bridge is exclusively to EVM chains and from Cosmos-based chains. Well, it goes both directions, but one end must be EVM, one end must be Cosmos. So obviously, Ethereum is a pretty expensive chain to run stuff on in general. So doing all of these header validations and actually doing the signature checking is just an expensive operation. So what we did for Gravity Bridge is that we took the design from over here, like really simple multi-sig set, and we asked, what is the minimum transformation we need to do to a multi-sig set to make it a validator set? So the answer for that is that multi-sigs don't typically rotate automatically. Validator sets do rotate automatically. Otherwise, there's a lot of things in there, slashing for equivocation, slashing for double signing, a lot of different vulnerabilities that make a proof-of-stake consensus algorithm. But what we designed is the simplest transformation. Instead of taking the normal chain headers, we take Instead of taking the normal chain headers, we described a very minimal proof-of-stake protocol that is sufficient to update the validators on the Ethereum side very efficiently. And what does that get us? So that gives us an enormous amount of design flexibility. Our code on Ethereum is much simpler in exchange for more complexity on the Cosmos side, which is cheaper to run since we don't have to pay gas over there. And the final outcome is that we can design batching. And what batching is that because we are not actually relying on the chain headers from the Cosmos, since we're not actually relying on the chain headers from Cosmos, we can define operations ourselves. And that includes a really basic rollup. So what that means is that with every other bridge in this trustless column over here, you individually pay. So let's say that I'm trying to take tokens from the bridge blockchain back to Ethereum. You individually have to pay with your gas the entire cost of that verification, so a couple $100. With Gravity, we define a batch of transactions, and you can think of this as a metaphorical bus. And people come and wait at the bus stop and put their money in the jar, and when there's enough money in the jar, the bus goes to Ethereum. And this brings our average withdrawal cost, provided you're willing to wait for a full bus, from that $200 to $400 range down to below the base cost of a transaction on Ethereum. So today that would be on the order of $16. So that is how much cheaper it is to move tokens from Cosmos to Ethereum with Gravity Bridge than it is with these other chain designs. And that is possible because we were able to use our very simple, very compact bridge update protocol, which is kind of like a proof-of-stake protocol. I don't want to really call it one fully, but you can think of it that way, to define a new operation that gets us this incredible efficiency and lets us take these ideas from rollups and apply them. And this is where Gravity starts to get really generically useful, or useful to other projects in the ecosystem. Because we have defined because we have defined Gravity as a module that any Cosmos-based chain can use, anyone can run one of these bridges and start to aggregate transactions to get these low costs. So this is a graph of, a diagram of how the bridge works in general. And you see it's pretty much what I've been talking about so far. People deposit. This is very, very normal for any given bridge process. And then when they withdraw, their transactions are bundled together into a batch that executes all at once on Ethereum and acts as a very simple rollup, and thus reduces transaction costs. Yeah. So from here, I want to go on to the sort of even more exciting part of this, which is where this is arbitrarily expandable. So more than just basic transactions, more than just taking tokens from one chain, minting a representation on the other, and sort of moving them back and forth. It is possible for the validator set of the Cosmos blockchain to define an arbitrary execution on Ethereum and batch them together. So this gets into interesting actions. For example, you could batch together 100 different arbitrage trades for Uniswap and decrease your gas cost. And this ties back with what I was talking about earlier. Gas costs, for at least for DeFi trades, are typically a matter of waiting until the arbitrage opportunity is big enough that you make money. So if you reduce the gas cost, you increase arbitrage opportunities. So this sort of has a feedback loop effect, where by using the consensus of the external chain to bundle operations, you can dramatically increase the efficiency of every individual transaction. And so, yeah, this opens up a lot of interesting opportunities for cross-chain operations and cross-chain development, where you can do things on Ethereum that aren't otherwise possible. And there are currently some chains already running in production on Ethereum performing these sorts of actions. For example, Solidity has no way to perform a timed operation other than having somebody send in a transaction to do it for you. And you could either design an entire system to make that work, or you could run it with, well, there are lots of ways to make that sort of thing work. But with Gravity, you could have an external chain with external consensus actually produce these operations on Ethereum and do something that otherwise is not possible with Solidity in a decentralized way, without having to, while dealing with different constraints than if you were trying to do this with a generic like relayer or just somebody can call this endpoint architecture. Yeah, so I think that covers most everything I wanted to. There we go. I knew I was forgetting something. So, for those of you not familiar, IBC is a bridge protocol for that operates between Cosmos-based chains, and it's actually on the list, about halfway down there, of these trustless bridge protocols. It only goes from Cosmos to Cosmos, so Cosmos-based chains to Cosmos-based chains, and this is where Gravity Bridge becomes very even more interesting, or has more features, is that you can chain a bridge to Ethereum with a bridge over IBC. So Gravity Bridge gives you access not only to the Ethereum ecosystem from a Cosmos-based chain, but the entire Cosmos ecosystem from an Ethereum-based chain, or EVM-based chain. And this sort of double bridge usage is a kind of new. Bridges themselves are kind of new, and going in with a strategy of, hey, let's run tokens through one bridge and then run them through another, is definitely interesting, and we'll sort of see how that works out in the sense of creating hyper-efficient bridge hubs. Because what I've been discussing this whole time is how batching operations acts like a rollup and reduces costs on Ethereum. So if you can use IBC as a lower cost bridge between proof-of-stake chains, or between Cosmos chains which are currently proof-of-stake, which means they currently have lower transaction costs than Ethereum, then you can start to aggregate the entire Cosmos ecosystem worth of transactions to Ethereum, run them all at once, and save really enormous amounts of gas performing the same operations. And I think that is everything that I wanted to cover. I've left a good bit of time for questions here because there's enough to talk about when it comes to bridges that you can't fit it anywhere near in a 30-minute presentation. And it's very hard to get anything even like sensible in that size. So I am interested in what everybody thinks and what questions they have.
How long does it take the batches to get filled and sent over?
Yeah, so the question was, how long does it take the batches to get filled? And the answer is, it takes as long as it takes for however many people to show up and send a batch. But even in the worst case, you're only paying what you would have to pay with any other bridge. Let's say you came up to the metaphorical bus stop and said, okay, I need to go right now. I am going to put $200 to $400 in here and just go for it. Well, then you will go over to Ethereum, just your transaction, and you will have paid, and you will be no worse off than if you had a design that didn't have batching. So this is also where IBC comes in as an important component, because the more activity you get through one bridge, the less time anyone has to wait, and the lower fees they get. And something that I didn't mention earlier is that due to this scheme, the average cost actually ends up lower than the base Ethereum transaction cost. So around 23,000 rather than 24,000, which is the minimum cost to do anything on Ethereum. Because by the time you pay for that 200 to 400,000 gas that it takes to verify all the signatures, which we're still paying for, we're just amortizing it over more people, you've actually paid less than even the entry-level cost for a transaction on Ethereum. Yeah, so NFTs is something that we have taken pains to make it possible to update the bridge, because the bridge itself is not, so the bridge contract is designed to be so compact that it doesn't need an upgrade proxy or anything, because that's obviously another point that you'd have to try and decentralize. So not currently, but we hope to upgrade to it soon. Yeah, so arbitrary execution is sort of a fraught problem in general, because the bridge is obviously holding all the transactions. So it's not really safe to do arbitrary things arbitrarily. So what we have right now is that the validators can come together on the Cosmos chain and say, okay, we want to run this exact contract call. So it's essentially a delegate to, and you just put in the bytes that you want to call and the contract that you want to call and all the tokens you want to send it, and it executes it. Now, obviously, making that safe and deciding whether or not the transaction is safe is punted to the validator set for now. And what you can do, obviously, this is a concession to the fact that we can't update the Ethereum contract, but we can update the proof of stake. So we can update the validator set by getting everybody together and having them all vote, like, we're going to upgrade the software on the Cosmos side. So that is how we would implement some way to generate these arbitrary transactions, which probably wouldn't be so arbitrary in actual practice, just in the name of practical security. So you would say, like, hey, we want to make this really specific type of thing. And they would use this endpoint on the Gravity contract to let them do that specific type of thing safely. Because the Gravity contract can call any contract with any argument that the validator set deems wise. But deeming it wise is the hard part.
Is there a replace by fee type mechanism? So if I'm waiting at a bus stop and I decide, I really need to speed this up, I thought it was going to be faster, I can pull out my wallet and pay a little bit more?
Yeah, so the question was, is there a replace by fee mechanism so that you can speed up your wait at the metaphorical bus stop? And the answer is, right now, yes, in a limited context. So once your transaction, once it's possible for it to be relayed to Ethereum, once it is actually placed, so like once it's metaphorically on the bus and the bus is waiting to go, you're stuck. You've got to wait 8 hours for it to time out. But until then, you can always walk away and come back with more money. And even then, we can actually get that the average wait time, if you have too low of a fee, will be significantly less than 8 hours for, because there's a timeout scheme where if another batch goes, it can preemptively make that batch impossible, and it lets us let you take your transaction off the bus without risking double spending, because it's all really down to the fact that, oh no, the validators have started signing this batch. It might be executable. We don't want to even risk, we don't want to have any risk of the batch executing when we said, no, we took these transactions out. Well, cool. I don't know how I'm doing on time.
I think you're good.
Oh, excellent. Yeah.
Yeah, is the withdrawal time ever going to speed up?
Oh, the withdrawal time is, so
Or is it always going to be reliant on how full the bus is?
it's always going to be reliant on how much money is in the pot to move the bus, because there are relayers that are running this. And what's actually interesting is that we designed our entire relayer scheme for Gravity to essentially exploit MEV on the Ethereum side, because it pays to transaction.sender. So once anybody tries to publish the batch, you might not even need money in your relayers, because as soon as you put that transaction into the mempool, somebody's going to snipe it and make the batches execute faster. So yeah, there's no good way to make it execute faster other than paying more, which is why the other bridges in the ecosystem have ended up with the 200 to 400, because that's what it costs to send something from a decentralized separate chain and validate all the signatures on Ethereum. You can't go below that. You can only put more people on the train or bus, to keep one metaphor going.
Is there a type of visualizer or way to tell how full the bus is while I'm waiting on my transaction to confirm?
Yeah, so the question was, and I keep on forgetting to repeat the question, so I'm sorry for people watching the recording of this in the future. The question is there an easy way to see how full the bus is before you go and place your transaction into the pool? And that's a component of the front end, which is not ready yet, but is something that I'm excited to be working on and really display to the user their choices, like how long can you expect to wait versus how much can you expect to pay. So there are 2 chains currently running Gravity Bridge, their own slightly modified forks in production, and we will be launching our own Gravity Bridge chain within the month. So we are really close to going live, and I'm very excited. This has been a little more than a year of a journey, and I'm really happy with how it's turned out, because like I explained in the beginning, we started with these really, really crisp goals, like this is what we need to achieve, and we have sort of thrown our dart design-wise, and it's landed where we wanted it to.
You mentioned you can use some of this functionality to like batch cross-chain transactions. That's not something that's like you have developed to happen right now at the moment, or that's just like hypothetically possible.
Yeah, so that's a good question. The question was that we have software to batch cross-chain transactions, and is that something we have now, or is that a hypothetical thing? And yeah, that's a good question. So for basic ERC20 transfers, batching is implemented and works as is, and will be ready on launch. For arbitrary other logic, batching has to be developed. So if you wanted to do something like that mass Uniswap arbitrage batch that I was talking about, that would have to be developed as a separate thing. So basic back and forth is already batched. Batching of other things is possible.
What's the average wait time you've seen the bus waiting? Is it always hours or is it minutes?
So the question was, what is the average wait time? And that depends on getting a high activity Gravity chain going, and also what token you're trying to bridge, because we bridge one type of token per batch. Right now, we could use arbitrary logic to bridge different types of tokens per batch. That's not currently developed. So the average wait time on an active bridge, we're hoping it is on the order of minutes, especially for things like stablecoins, really, really popular tokens. There will be enough people around moving transactions back and forth to really make it a smooth and crisp experience for the user. But once again, I'll always go back to, Even if you have to pay the full price or wait, it's always better than you have more options than were previously possible. And that does bring complexity in the UI and in how users interact with this software, but the extra options are nice to have.
This might be an offline question, but I'm just kind of curious about the actual development processes of things this complex, and how do you actually sit and work through it every day and make sure there's no bugs. Like, I can just imagine you guys sitting around working and finding defects and thinking through. So might be an offline question, but I'm interested in that.
Yeah, so 1 second, let me check and see if I have time. And it looks like I still do. So to sort of repeat the question, what is the actual development process for things this complicated like? This is something that I'm really passionate about. Is how we do engineering at Althea. Is that we believe in really compact, in like really compact designs, really how should I put it? Simple engineering. So we spend a lot of time putting our heads together and being like, well, how do we want to do this? How can we take these parts out? And then as we go and we try to build it, we keep trying to take parts out. We keep trying to ask, what do we really need? How do we throw out everything except for that? And most importantly, you have to have conviction with your design. If you try and do everything well, you will end up with something that is bad at everything. You need to really commit to doing, you need to really commit to your design decisions and go all in on them. You can't try and be like, oh, I want to compromise on this and compromise on that. No, you've got to really go straight for it. So in this case, our choices were that we were going to really commit to not being generalized in the sense of we could go to multiple chains. It's got to be an EVM chain on one end. It's got to be a Cosmos chain on the other. We also decided to develop this really simple update protocol while focusing and put all of our chips on the table for, hey, we want to move the complexity over to the Cosmos side where we get to code and go rather than Solidity. More importantly than being able to code and go, we can update it with consensus. So then for the arbitrary logic stuff, we worked really hard on making sure that it was compact, simple, straightforward, and that we didn't have to deal with figuring out how to actually use it too safely before we launched. We can say, like, it's possible. There's lots of potential pitfalls, but we can do those later. So yeah, the answer is to, at least in my opinion, to keep a small team, keep them very focused on what they're doing, and to come in every day and ask, do we really need all of this or can we throw it out? Because really, really incredible engineering is when people come in and you show them your design and they're like, oh, that's really straightforward, what's next? They don't have to stop and say like, oh, you sound really smart. No. If your engineering design sounds smart, you're in for trouble because you need to be smarter than the design in order to debug it. And so you'll end up in a situation where you're not smarter than yourself and you can't finish getting things working. This is actually the #1 problem we identified. We looked at a history of cross-chain bridge development and particularly projects that failed. And we did sort of a pre-mortem and said, why did these projects fail? And the answer was they tried to do too much indirection. They tried to buy down too much risk. They took these inherent risks and they tried really hard to mitigate them to the point where they added complexity on top of complexity on top of complexity. And suddenly their complexity is a higher risk than the thing they were mitigating in the first place. They weren't willing to commit. And that's why we really went in and said, simplicity, commit to a design principle, and really see it through to the end. And the hard part of that is always knowing when you need to step back and redesign versus when you need to put your head down and plow through. And that is just craftsmanship. That can't be taught. So I think we're out of questions. Ooh.
What do you anticipate the numbers of
So the question was, what do we anticipate the number of Althea routers to be on launch? And the answer is that, so I co-founded Althea in 2017, and we took the sort of interesting approach of flipping the problem. We said, Althea routers need cheap and reliable microtransactions, and current blockchains don't really provide that. But at the time, 2017, 2018, ETH transaction fees were low enough, and I'm like, hey, it's close enough. We can go for it. So Althea currently has several hundred homes and businesses running Althea routers right now. They're trading on XDAI currently, so that they have a stable coin and relatively low transaction fees. And this has been a great way to prototype our software, get our stuff out to real users. We have regular people using this software, a Subway restaurant, a nurse providing telehealth visits, and we have an ambulance barn, a fire station, that's all running Althea right now. And this has let us really prove out our idea, prove that customers want this, and make the networking software work. And now we have to step back and say, well, okay, the blockchain, we have ignored this component for a while. What does it need? And the answer is that what Althea wants out of its blockchain is fundamentally different than most existing blockchains are. These are financial blockchains. If a transaction goes in and the person who paid the highest transaction fee doesn't get in first, that is considered an inefficiency in Ethereum. But on the Althea blockchain, our goal is predictability. You don't want your Netflix to go out because there's an NFT drop. You don't want, under any circumstances, payments to be unpredictable or held up. So different requirements drive fundamentally Althea as a telecom infrastructure blockchain versus a financial blockchain. And that is why we are going to be working on launching the Althea blockchain and adding new routers on the new system and moving users as they desire over to the Althea blockchain, where they can have a more reliable experience. So I hope that answers your question and like everything else behind it. It's a bit of a rant, I'm sorry. Yeah?
So then I guess following up on that, are your Althea users currently only in the US, or are you having plans to have it more globalized? Because it seems like this would be really useful for other countries as well, especially ones where internet accessibility isn't as simple.
Yeah, so the question was, where are Althea users currently? And most Althea users are currently in the United States. We have networks in 3 countries where we've been sort of experimenting with developing markets. But there's a whole different lecture that I want to give on how I designed Althea to dramatically reduce the cost to deploy. And some of those simplifications make it not the best for developing markets right now. So we're working on developed markets, particularly the United States, and we're going to move into developing markets as we have the capital to really develop something that's a good Althea router for the emerging world, which essentially means it needs a big battery in it because power is unreliable and expensive, which we can't afford to manufacture. So that is sort of where we are right now. Our experiments in the developing world have shown that the model is feasible. Like you can get enough phone users on a home router. The home router costs the right amount of money. They're willing to spend the right amount of money. You can get backhaul. You can get local people to participate in the system and help build this economy, but just can't solve the sort of power, electricity, and security. We've got to solve 2 layers of infrastructure problem, and we're not ready for that yet. Cool. So I think that's all of my time today. Thank you very much, everybody.